So the review for the test on Canvas, the test review, focuses on the newer stuff. But again, make sure you look over the quiz, study the quiz, and web assigned questions to prepare for the test. But we're going to do a few questions of each type from the review. So let's start with number 5. So here I'm expanding my log. So when I have division, what goes with division? Subtraction. So we'd take log of x minus log y to the 5th power. What do I do with the exponent? Move it in front of that log. So we've got log of x minus 5 log y. I'm going to do a bonus question here too. Let's say I had log base 4 of the square root of, let's say, x to the 3rd power over y. So this is just an extra example. What would I do here? Olivia. Awesome. So because the x to the 3rd power and the y are under the square root, a 1/2 is going to go in front of both of them. So, and I'm going to separate them with subtraction since I'm dividing. So this would be log 1/2 log base 4 of x to the 3rd power minus 1/2 log base 4 of y. Now what would I do with the exponent that I have here? What do I do with the exponent? Joy, what do we do with the exponent? We move it in front. But if I already have a number out front, what do I do with the two numbers now? Multiply them. So this would be 3/2 log base 4 of x minus 1/2 log base 4 of y. Perfect. So because that square root was over the x and the y, make sure you know that if we have the square root of x, that's the same as saying x to the 1/2 power. So that's why we put the 1/2 in front of the x and the y. Question?
If you put the 1/2 in front of all of it with brackets, will you get wrong?
That's the same. It depends on if you do it correctly. So if you had 1/2 and then you put brackets, 3 log base 4 of x minus log base 4 of y, this would be fine. Let's look at 8. We're going to be condensing it. What should we do first when we condense our log? We take our coefficients and make them exponents. So we've got log base 2 of x to the 1/3 power plus log base 2 of y to the 3rd power minus log base 2 of z. What do we do with the 1/3 power? How could we write that? Rewrite that. What would x to the 1/3 power change to? Awesome, the cubed root of x. So this would be the cubed root of x. Now what goes with addition? Multiplication. So I'm going to multiply these two together. So we've got log base 2 of the cubed root of x times y cubed. And then what goes with subtraction? Division. So divided by g. So we talked about this in the notes a little bit. If we are subtracting multiple things, so if I had, let's say, minus log base 2 of w, for example, anything that's being subtracted goes on the bottom, so that w would go on the bottom too. So anything being subtracted would be being divided, so it goes under the division. So it goes in the bottom of your fraction. Yep, so it should be z to the 7th power. Forgot about the 7. Perfect. Thank you. Any questions here? Awesome. Let's go to the next page. So let's look at 11. 11, we're going to be solving. So whenever we're solving, we always want to get the base with the exponent all by itself. What would we have to move first here? Add 14 to move it to the other side. So 3e to the power of x equals 25. What would we do next? Divide by 3. So e to the power of x equals, you can leave it as 25 over 3, or if you want to put it in your calculator, it'd be 8.333 repeating. But keep it in your calculator since it keeps going. What would we do next? Awesome. ln cancels out that e, so we're going to take the ln of both sides. So the ln of e cancels, so we're left with x equals the ln of 8.33. So we'd have to put that into the calculator. So when we put this in the calculator, you get 2.1202. The test will be specific on how many decimal places it wants. Perfect. So let's look at 20. So there were a couple like these from the WebAssign. We didn't really talk about them in this class, but I think there might be a couple in the video from the notes. But these look super similar to a regular quadratic equation. The only difference is instead of just having x or x squared, we have e to the power of x or e to the power of 2x. So we're going to treat this as if it were a quadratic equation. We're going to factor it. So this is like saying 2 times x squared minus 5 times x minus 3 equals 0. So anytime you have e to the power of 2x and e to the power of x, we can't combine these together. They're not like terms. So we have to factor. So we're going to factor. How would I factor this? What should I do first? Do we have a GCF? No. So then what do? Multiply the first times the last. So 2 times negative 3 would be negative 6. What are 2 factors of negative 6 that add to negative 5? Negative 6 and 1. Perfect. So x minus 6 and x plus 1. What do we have to do next? Divide by 2. So this becomes x minus 3 and 2x plus 1. But we're not actually talking about x here. We changed x to be e to the power of x. We changed e to the power of x to be x. So we got to change it back. So that x, I'm going to erase the x and replace it with what it should have been, which is e to the power of x. So you factor like normal as if it was just x, but don't forget to replace it back with e to the power of x. Now we're going to solve. So I set them both equal to 0. So e to the power of x equals, minus 3 equals 0. And 2 e to the power of x plus 1 equals 0. Let's solve. For our first equation, the one on the left here, what would we do first to solve? Add 3. So we get e to the power of x equals 3. What would we do next? Take the ln to cancel out the e. So we take the ln of both sides. It cancels out the e. We're left with x equals ln of 3. We're going to put that in our calculator. So x equals 1.0986. So that would be one of our answers. Let's do the same thing with the other one. We're going to subtract 1 and divide by 2. So e to the power of x equals negative 1 over 2. What would we have to do to cancel out the e? Take the ln of both sides. So x equals, what happens if you put the ln of negative 1/2 in the calculator? Error. It doesn't work. So do we get a solution here? Nope. So that's just not an answer. It doesn't mean that this question's no solution. We did have a solution as an answer. We just don't have two answers. So that might happen. You might end up with two answers. That's totally fine. Two answers might work. It might be the case that neither work. Just got to work it out. And if you get error, it's probably just because it's not a solution there. It just doesn't work. So let's look at 28. So we want to get the log all by itself here. What would we need to do first? Subtract 5. So 1/3 log base 2 of x equals 2. What would we do next? How do we move that 1/3 to the other side? Multiply by 3. So it cancels, so we have log base 2 of x equals 6. Now how do we get rid of the log? Make the big base 2. So since our little base of the log is 2, I'm going to make the big base 2 on both sides. So 2 to the power of log base 2 cancels. We're left with x equals 2 to the 6th power. So we made the big base 2, so that 6 became our exponent. 2 is our base. So in our calculator, you can put 2 to the 6th power. What do we get? 64. If you want to, you can plug it back into your question and see if it works, see if it makes sense. All right, let's look at 30 right below it. What should we do here? So we know if we have a log equals a log, we can cancel them out. But here, I can't just move a log to the other side because I have that 1 on the other side. So let's condense it down to a single log. How do I condense it when I'm subtracting? Divide. Before I can condense these, what would I have to do first? Put the exponent. I'm going to make the 2 an exponent on the x. So then we can divide. We've got log base 4 of x squared over x minus 1 equals 1. So now, how can we get rid of that log? Make the big base 4. Perfect. So we're going to make the big base 4 on both sides, or put it into exponential form. So 4 to the power of log base 4 will cancel. We're left with x squared over x minus 1 equals 4 to the power of 1. What's 4 to the power of 1? 4. How would I solve from here? What should I do next? We can multiply. If you want, make it 4 over 1 and cross multiply. So we've got x squared equals 4 times x minus 1. We can distribute the 4. So x squared equals 4x minus 4. If we have an x squared and an x, how should we solve? What are we going to have to do? Factor. But if I factor, what does it have to be equal to? 0. So we got to move all of our terms to one side. I like to factor when my x squared is positive, so I'm going to move the 4x and the 4 to the other side. So I'm going to subtract 4x and add 4. So we get x squared minus 4x plus 4 equals 0. Now we can factor. What are two factors of 4 that add to negative 4? Negative 2 and negative 2. Perfect. So x minus 2 and x minus 2 equals 0. So what does x equal? 2. Awesome. When you're dealing with logs, make sure you check for extraneous solutions. What can I not take the log of? Can't take the log of a negative. Can't take the log of a negative. What else could I not take the log of? or 0. Can't take the log of 0. Try putting log of 0 in your calculator. What do you get? Error. So if we plug in 2, I can take the log of 2. That's fine. And then 2 minus 1 would be 1, so it works there too. So 2 would be my answer. So check for extraneous solutions, especially when you're dealing with logs. All right, I want to do one more bonus one with you. Let's say I had log base 2 of x plus 5 minus log base 2 of 10x equals 0. What could we do here? You can make it into one log. Does anybody else have any other suggestions? What if I added my log to the other side? Add log base 2 of 10x. So we get log base 2 of x plus 5 equals log base 2 of 10x. When I have a log equals a log, what happens? They cancel. You can totally combine them to be one log and then put it into exponential form. You'll end up with the same answer. And it's probably the same amount of steps either. I just wanted to show you guys this way. If it equals 0, move your log to the other side, because if you get a log equals a log, they cancel out. So we have x plus 5 equals 10x. So we can subtract x on both sides. 5 equals 9x and divide by 9. So x equals 5 over 9. So on the test, you're going to have to graph an exponential function and a log function. You also need to know your compounding formulas. So make sure you know your compounding formulas too. So let's say, as an extra example, if we had f of x equals 1/2 times 4 to the power of x plus 2 minus 3. And it asks for the domain, range, horizontal asymptote, vertical asymptote, and y-intercept. And we'll graph it. So when we have exponential functions, our exponential function is either going to be growing like this or decaying like this. Unless you have a reflection, then it could flip along either the x-axis or the y-axis, so it may be decreasing like this or like this. So if you have a reflection, but do we have a reflection here? No, we're not multiplying by a negative, so we don't have a reflection. Does our graph show exponential growth or exponential decay? What do we think? So we look at the base. If our base is greater than 1, what is it? Growth. We'll have exponential growth. So our graph's going to look like this, the yellow line here. I'll redraw it. Our graph's going to look like this. It'll be some variation of this because it's going to have shifts happening, but it's going to be increasing like this. This tells us that we have exponential growth. So it helps to know the general shape of it. What's our domain going to be for all exponential functions? All real numbers from negative infinity to positive infinity. Our range and the horizontal asymptote go hand in hand. For exponential functions, you only have a horizontal asymptote. Some people on the quiz put both. We don't have both. You're not going to have both for exponential functions or log functions. We only have a horizontal asymptote for exponential functions. Our horizontal asymptote's based off of what? What number here tells us what our horizontal asymptote is? The -3. What we're adding or subtracting on the outside, so the big number that we're adding or subtracting, tells us our horizontal asymptote. So horizontal asymptote would be y equals -3. So what's our range going to be? From -3 to infinity. It goes to infinity because we don't have any shifts happening here. Our graph's going up to infinity. We can draw that on our graph now. We're going to put our horizontal asymptote at -3. What's our vertical asymptote? There is none. You're only going to have one or the other for these types of graphs. Exponential, you're going to have horizontal. How do we find the y-intercept? Awesome. Plug in 0 for x. So we've got 1/2 times 4 to the power of 0 plus 2 minus 3. So 1/2 times 4 to the second power minus 3. Make sure you follow your order of operations. You have to do the exponent before you multiply. Yeah. 4 squared would be 16. So we have 16 over 2 minus 3. What's 16 divided by 2? Or 16 times 1/2. 8, and 8 minus 3 would be 5. So our y-intercept would be 0, 5. So I'm going to cross the y-axis at 5. So I have a point there. Now you can plug in more values. On the test, it's going to tell you what values to plug in. It'll give you a chart, plug in your numbers, see which way your graph goes. But we know that it's going to start down low and end up going up. So our graph's going to look like this-ish, something like that. It'll go through that point. But you'll plug in more values. Plug in something like -1, -2, and see what you get. Just to give you more of an idea. Actually, let's do that, just for fun. Let's plug in -2. So if we plug in -2, we have 1/2 times 4 to the power of -2 plus 2 minus 3. -2 plus 2 would be what? 0. What is 4 to the power of 0? 1. So here we have 1 times 1/2, which would just be 1/2. And 1/2 minus 3? Well, we can make a common denominator. This would be 6 over 2, so this would be -5 over 2. Or, to help you graph it, you'll have your calculator with you for the whole test. So put it in the calculator if you need to. -5 divided by 2 would be -2.5. So a better, more accurate example of our graph would look like this. We plugged in -2 and got -2.5, so down here. So our graph would look more like that. But it's got that same shape, it's still increasing. Awesome. Let's do a log graph. So an example, we'll just call it an example. So f of x equals log base 2 of -4x plus 3. We want to find the domain, the range, the horizontal asymptote, vertical asymptote, and x-intercept. So our log graphs are either going to look like this if our base is greater than 1. Or it'll look like this if our base is a fraction. But it could change if we have a transformation. Do we have a transformation here? What does a negative on the inside do to our graph? It's a reflection on which axis? Inside. X or Y? Reflection on the y-axis. Remember, x's are outside. If you had an ex-boyfriend, you'd want them outside of your house, right? So inside y-axis. So we've got a reflection on the y-axis. So here, our base is greater than 1. So we've got this shape. But since we have a reflection on the y-axis, it's going to flip. So it's going to be like this. I'll redraw it here for us. It'll look like this. Because it flips along the y-axis. So it helps to know the general idea of our graph. Now let's find where exactly it's going to be. Let's find all of our important information. Well, let's start with what's the easy one here? The range. What's our range? All real numbers, negative infinity to positive infinity. Here we're going to have a vertical asymptote. With your logs, you have a vertical asymptote. So there is no horizontal asymptote. How do we find the vertical asymptote? Set the parentheses equal to 0. So we've got negative 4x plus 3 equals 0. Subtract 3 and divide by negative 4. So x equals 3/4. So our vertical asymptote is x equals 3/4. So it'll be just short of 1. Our graph, we said, is going to go in the left direction. We can find our x-intercept too. Let's do that next. How do we find the x-intercept? Plug in 0 to y. Remember, y is the same thing as f of x, so we're setting it equal to 0. So 0 equals log base 2 of negative 4x plus 3. How do I solve a log equation? What do I do? You can put it into exponential form or make the big base 2 on both sides. What's 2 to the power of 0? 1. 2 to the power of log base 2 will cancel, so 1 equals negative 4x plus 3. Subtract 3. We get negative 2 equals negative 4x. Divide by negative 4. So x equals 1/2. So our x-intercept would be 1/2 comma 0. So it's going to be about there. And we know the shape of our graph. It's going to go to the left here. So our domain goes with our asymptote. Our domain, is it going to be to positive infinity or to negative infinity? Negative infinity, because it's pointing to the left. So it'll be negative infinity to 3/4. Have a great weekend.